All right, good morning, good afternoon, whatever it might be for you. I'm going to run through this lesson for you real quick, and then you guys will have the rest of the time to work on your homework, and then Mr. Day will pass out the review, and you can work on that and get that done for tomorrow. All right, so today we're going to learn about 11.5, the recursive rule for sequences, and your homework is below. That should be assignment 3 for tonight, and you're also going to do the review that Mr. Day is going to give you at the end of class. Alright, so the objective for today is just to evaluate and write recursive rules for sequences, both arithmetic and geometric. So here is some text. Don't worry about writing this down. So far, the rules we found, a sub n, for a sub n, have been explicit rules. They give you the value of a term from the term number. If you want the 50th term, then you put in 50 for n, and you get the 50th term. A recursive rule gives you the beginning term and then tells you how to get the next term from the previous term. So the recursive rules express the pattern as you were to explain it to someone else. So the only issue with these recursive rules is if you want to know the 50th term, you have to also know the 49th. So it's not as effective of a process for solving for a certain term, but we're still going to learn about it regardless. So here the first thing it wants us to do is find the first 5 terms of the sequence. So it gives us A1, and then it tells us our recursive rule here. A sub n minus 1 plus 5. This 5 is going to end up being our D, so we'll notice this structure here. So first, if I want to find A sub 2, which would be the second term, I just plug 2 in for n, so that would give me A sub 2 minus 1 plus 5. So A2, 2 minus 1 is A sub 1 plus 5. And I know now that A1 was 3. So A sub 2 equals 3 plus 5. So that's 8. So I now know I have 3, 8. And yes, you probably know the common difference is 5, so you could just go from here. But just in case, for A sub 3, I'm just going to do A sub 3 minus 1 plus 5. So A sub 3 equals A sub 2 plus 5. And I just found that A sub 2 was 8. So that would be 8 plus 5, which would give you 13. Alright, so all that A sub n minus 1 means is the term before the one you're trying to find. So now if I'm trying to find the fourth term, I just do 13 in place for the A sub n minus 1 plus 5. So I'd get 18. Alright, and then I add 5 to that, and I'd get 23. So that's what the recursive rule tells us. We use the term before the one we're trying to find to ultimately get the term we're looking for. Alright, down here we'll see now we have a geometric recursive rule. Again, we still have A sub 1. So the process is the same. Anytime you see this A to the n minus 1, that just means the term before. But I'll go through and work through a couple anyhow. So this will be 2 times A sub 2 minus 1 because I'm looking for A2. So I'm plugging in the 2 here. So A2 equals 2 times A1. So A2 equals 2 times A1 is 3. So A2 equals 6. And again, I can do the same thing. A sub 3 equals 2 times A sub 3 minus 1. So A sub 3 equals 2, A sub 2. A sub 3 equals 2. A sub 2 we just said was 6. So A sub 3 is 12. And you'll see the process is just going to continue multiplying by 2. So you'd get 3, 6, 12, 24, and 48. And that would be the first 5 terms of that sequence. Now we're going to look at how to write the explicit and recursive rules for the following sequences. So we just looked at some examples of a recursive rule um, setup, where for the arithmetic we had a sub n minus 1 plus or minus d. So we have a sub n equals a sub n minus 1 plus d. And then for geometric, it's just r times a sub n minus 1. So this is for arithmetic, this is for geometric. And then if you remember your explicit rules, a sub n equals a1 plus n minus 1 times d, and a sub n equals a1 r to the n minus 1. So it asks for both of those. So the first thing we have to do is determine if it's arithmetic or geometric. So we can do that by looking to see if we either have a common difference or a common ratio. So the first thing I'm going to check for is the common difference. Here it's pretty clear that I'm subtracting 6, subtracting 6, subtracting 6. So I know D is negative 6, A1 is 17. Alright, so I'm going to go ahead and I'll first get the explicit rule, since that's what we're familiar with. So A1 is 17 plus n minus 1 times D, which I said was negative 6. Alright, so we get, just simplify, so plus negative 6n plus 6, so I end up with 23 minus 6n is my explicit rule. And then for my recursive rule, I'm just going to have a sub n minus 1. A sub n equals a sub n minus 1 plus d, which is just going to be minus 6. So this here is my explicit, which is what we've been doing the last couple of days. And here we have the recursive rule. So nothing too bad, especially with the arithmetic. All right. We then go to our geometric, or we can see it's geometric. It looks like we have 84 over negative 168, negative 42 over 84. So we're ultimately going to have negative 1/2 as my common ratio. A1 is negative 168. So I'll go through and write my explicit rule. So from the top, I know that's A1, so negative 168, times R, negative 1/2 to the n minus 1. So that's just simply putting that in to this right here. All right. For my recursive rule, all I'm doing is a sub n equals r times a to the n minus 1. So a sub n would equal negative 1/2 a to the a sub n minus 1. And that's really basically everything for the lesson for today. Like I told you yesterday, it was going to be pretty simple. So hopefully there aren't any questions. If there are, I'm sure Mr. Day can help you with them. Other than that, you guys can now work on the homework assignment for this section, and then at the end of class, or if you finish that, you can work on the exam review, which we'll go over tomorrow. Hope you guys have a great day.